Welcome to our review session on April 11th, 2023.
I accidentally started the video a little bit late. So this is number 25. Okay, so net displacement is the integral from 0 to 6 of vt dt, which is the integral from 0 to 6 of t squared plus 2t minus 15 dt, which is the antiderivative. T to the third over 3 plus 2t squared over 2 minus 15t from 0 to 6. The nice thing about 0 is that when I plug in 0, it's going to be 0. So let's just plug in 6 and see what happens. 6 to the third divided by 3 plus 2 times 36 divided by 2. Well, that's just 36, okay? Minus 15 times 6, which gets us 18. 18 meters. Net change of 18 meters in the positive direction. I'm going to get out my key just to make sure I don't screw anything up. Yep, 18 meters. Perfect. All right, that is net displacement. So how does that differ from total distance traveled? Well, remember that along from 0 to 6, I could be moving in the positive direction or the negative direction. So let's figure out when that's going to happen. So I'm going to say t squared plus 2t minus 15 equals 0. When the velocity equals 0, that means I've had a change in direction. So factor that, that's t plus 5, meant that to be a parenthesis, t minus 3. So t equals negative 5, t equals 3. So at 3 seconds, I change direction, right? At 3 seconds, I change direction. So that means I'm going to find the integral from 0 to 3 of vt dt, and then I'm going to add it with the integral from 3 to 6 vt dt. Now, one of these is negative. One of those is negative, and I need to take the absolute value of that because I want total distance traveled. Let's figure out which one is going to be negative. Well, what time period am I moving in the negative direction? From 0 to 3 or 3 to 6? Well, just plug in 1 and see what happens. At time 1, I'm going to have 1 plus 2 minus 15. Okay, that's definitely going to be negative, right? So at time 1, I'm moving in the negative direction, which means from time 0 to 3, I'm moving in the negative direction. So I just want to turn it positive. A couple different things you can do. You can take the absolute value of it or just take the opposite of it, right? It's going to be a negative distance traveled from 0 to 3, so just turn it positive. Find the absolute value, just make it negative, whatever. Okay, so let's do that exact same thing for both of these now. Okay, so I've got the antiderivative, which I still have up here, t to the third over 3 plus, and I'm just going to make that t squared, minus 15t from 0 to 3. And remember, I'm going to take the opposite of all that. Plus, we got t to the third over 3 plus t squared minus 15t from 3 to 6. Okay, so let's see what it is from 3 to 0, or from 0 to 3, rather. So 3 to the third, which is 27, divided by 3, well, that's just 9 again, plus 3 squared, which is 9, minus 15 times 3. So total negative 27 meters, right? I'm moving in the negative direction, 27 meters, but I'm still moving that distance, 27 meters. So negative negative cancels out, positive 27 meters, plus the distance from second 3 to second 6. So let's plug in 6. 6 to the third divided by 3 plus 6 squared, or 36, minus 15 times 6. Okay, so that gives me 18. Right, this is 18 minus, and then I've got to plug in 3. Top minus bottom. 3 to the third, which was 27, divided by 3, which is 9, plus 9, plus 3 squared, which is 9, minus 15 times 3, which is 45. Negative 27. So all said and done, that's 27 plus 18 plus 27. So I've traveled a total distance of 72 meters. Which makes sense because I moved in the negative direction 27 meters. I moved in the positive direction, what was this, 45 meters, right? So net distance traveled from above 18 meters. Questions about that? Okay, let's do question 26. Again, the key is online, all except for question 26. This is the only one the key is not online for. But I did already do a video of it. So, the daily electric power consumed by a typical household in a certain city can be modeled by that function, where P is the power in kilowatts and T is the time in hours. How much energy is consumed in a typical 24-hour time period? So basically, that is net change of power. Net change over from 0 to 24 hours of PT dt. Okay, so let's actually run the integral from 0 to 24 of 13 plus 0.25 t minus 0.01 t squared dt. Let's do the antiderivative. So which is 13t plus 0.25 t squared over 2 minus 0.01 t to the third over 3 from 0 to 24. And again, I'm just going to plug in 24 because if I plug in 0, that's going to cancel everything out. So 13 times 24 plus 0.25 times 24 squared divided by 2. I'm going to hit enter. Minus 0.01 times 24 to the third divided by 3. I didn't really need those parentheses, but whatever. 337.92. kilowatts. All right, what other questions do we want to go over? Anna Grace? 23. You
Whoa. Whoa.
All right. Now, do you know how to do quotient rule with an antiderivative? No. So I've got to get this fraction out of the way. All right. So now that means this is going to be 4 over radical x plus 6x over radical x dx, which, remember, that is x to the 1/2, right? So this is going to be integral of 4x to the negative 1/2. Now think about this. This is power of 1 over 1/2. What do I do with powers that are divided? Subtract. So this is 1 minus 1/2, or 1/2. Okay, now I've got powers that I can actually find the antiderivative of. So that's going to be 4x to the positive 1/2 over positive 1/2 plus 6x to the 3/2 over 3/2 plus c, because it's general, indefinite integral. All right, so 4 divided by 1/2 is 8. X to the 1/2 plus 6 divided by 3/2. So that would be 6 times 2/3, or 12 over 3, which is 4. 4x to the 3/2 plus c. Now, I would accept that as an answer. Yeah, I would accept that as an answer. But isn't the problem given to me in not fraction, but radical form? So let's put it back into radical form. 8 radical x plus 4 radical x to the third plus c. And honestly, that could even be reduced. You know, I could really say this. That's an acceptable answer, that's an acceptable answer, or that's an acceptable answer. Either one of those are fine. If I was being really nitpicky, I'd say you got to give me the bottom, but whatever. Honestly, that's just algebra, right?
Mhm.
This is the calculus. What other questions do we want to see? Casey?
I just have a question about two of them and their answers.
Yeah.
So for number 1, you had 3x squared plus 2 plus c. Did you see it x after 2?
Let me double check. Oops. Yep.
And then for 14, can you simplify that
What
down?
happened?
Number 1, the answer in the key to the book, or not in the book, in my notebook, is 3x squared plus 2 plus c. I forgot to add in my x right there. Right, so that is not in the key, but there should be an x in there. Yeah, you are right.
And then for 14, can you simplify that answer down low or no?
For 14,
Yeah.
no, because 48 is not divisible by. I'm sorry, excuse me. You know, you've got to be able to divide them all by 3 or all by 4. Yeah. What else do we want to see? 14? Okay. I don't hear you chiming up.
Because I know everything.
That's the best joke I've heard all day.
Last test I only missed 1 point.
That was the last test.
Last test I didn't miss any points.
It was a quiz anyway.
Oh.
If I was being critical of myself as a test maker, these really shouldn't be the same variable. Like this really should be like something different. I think I used a T on the quiz that we
Z.
had, or Z, whatever, right? Those really should be different variables. That might have confused you a little bit. But honestly, FTC1 just is the theorem that says that the integral is the opposite inverse operation of a derivative, right? So if I go to take the derivative of an integral, they will undo each other. That's why I say use FTC1, because I've got an integral sitting here, and I want to find the derivative of it. So I'm going to say find d over dx of that thing, which, and again, d over dx. That's why it's best to use a different variable over here, because this will cancel with these things. Okay? The derivative will cancel the integral notations. Now, what we have to do is take this piece and plug it in for t. So this is going to be 8 divided by 3x squared minus 2 plus 6. And that's finding the derivative of the integral. And we peel away that layer and now have to find the derivative of the 3x squared minus 2 because of the chain rule, which is 6x. Multiply the 6x up into the numerator, and that's 48x. And then on the bottom, that's going to give me 3x squared plus 4. And this is the question that Casey asked, should we be able to simplify that? And the answer to this one is no. Because I know 48 divides by 3, and I know 48 divides by 4, but to factor something out of the full fraction, everything is to be divisible by that number. So it would have had to have been like 48x over 3x squared plus 6 to divide it all by 3, or a 48x over 8x squared plus 4. Then I could divide it by 4.
To prepare for the test, should we do like half the test again for like the 1 half the day?
Yeah. I mean, that's what you can expect. Yeah, it'll go chronologically for the 2 days through the review. What else do we need to see?
9.
9. So you're saying no to me?
Oh,
9.
actually,
9.
can we do 7 after that?
Sure.
Oh wait, I think I remember how to do that.
Okay.
But we might as well do it just for fun.
I mean,
It's
I'm here for you.
Math is fun.
This is
we're not
what
gonna have
I
Math is fun.
this is I'm having a blast up here.
I bet.
There's no greater joy in my life than just being able to do math problems every single day. Yes. All right, evaluate the Riemann sum with n equals 6 for the following equation. I feel like I should have given you something a little bit more tricky than this. I mean, come on, right? I give you n equals 6 for an interval of 6 units. Delta x, 6 minus 0 over 6, b minus a over n. Oh, that turns out to be 1. I should have given you something more tricky, right? I mean, that's just easy. Like, come on, make it more difficult, right? So we have 6 minus 0 over 6 is 1, b minus a over n, right? Now, I'm going to be taking sample midpoints, right? And that's the difference, taking sample midpoints here. For the Riemann sum, remember, it's delta x times the sum, right? That's the easy way to put it. Delta x times the sum. So delta x is 1 times the sum of all the y values that you've got. So what am I going to plug in? Well, think about it. If I've got 6 widths, 6 rectangles, right? And my first interval goes from 0 to 1 because my width of my rectangle is standard to be 1. So if I'm going from 0 to 1, what's my first midpoint? 0.5. And then I can just keep adding 1, right? Because my next interval would go from 1 to 2, which is 1.5. And I can just keep that pattern. So 2.5, and then 3.5, and then 4.5, and then 5.5. And that will give me my 6 rectangles, the y values of each of these rectangles. And at this point, it just goes to your calculator, just plugging them all in. 0.5 squared plus 8, plus 0.5, nope, 1.5 squared plus 8, plus 2.5 squared plus 8, plus 3.5 squared plus 8, plus 4.5 squared plus 8, plus 5.5 squared plus 8, which gets me 119.5. Now, the issue here with midpoints is, do I know whether that's an underestimate or overestimate? No, I don't necessarily know whether it's smaller than it should be or bigger than it should be because I've gone in the middle. I can narrow it down by using left and right, over versus under, but for this here, it's just midpoints. I don't have that ability. What else would we like to see?
I think we're out of
I think we're all
time.
good.
So 6 minutes left. 5 minutes left.
Five and counting.
And we need
like 2 minutes to back up too.
We need 5 minutes to pack up.
I have to unplug my charger. That takes up a second.
I'm sure. Hey, I'm here for you. You know? Remember, don't forget, UCCP people, these tests, I mean, how many tests are we going to have in the semester? 4. Semester, not 9 weeks. 4. Right? We had the 4.1 to 4.4 test, the 4.5, 4.8 test, 4.9 to 5.4 test, and then we will have a 5.5, 6.1 test. Okay? And that last test is not even a full test. It's only a 1 day. Kind of smaller. Okay? So I'm just saying, be careful. Don't just be like,
I can go like, because I'm not CP.
okay, cool. Let me stop the video then.
No, you're CP. You're not CCP.
Thank you.